Okay, in this video what we're going to look at is data transformations. And when we talk about data transformations, what we're talking about is linearizing a bivariate relationship that is not linear. So I'll go through an example of what that means shortly. But what we can do is we can square the x values, log them, or reciprocal values, that's these ones here. Or we can do the y squared log of the y value or reciprocate the y value as well. You need to know how and when to use a particular set of these transformations, and then decide which transformation is the best model for the relationship. And we use that via two components, a residual plot and a coefficient of determination. And the reason we're doing that, because sometimes if your data sort of looks like that, and if I can sort of transform the data so that I get something that looks, I can fit close enough to that, I can, and you say that's here was y and x, that's now y squared and x. I can actually fit a line to that, but I'd have a value of y squared equals a plus bx, and then I solve for whatever I've got to do. I can actually do that, and that's why I can take this, transform it, from that transformation get that equation from here, and then I can go back and make predictions that will relate to this, because if I want y, eventually I'll just have to square root everything. That's the reason you want to do it, because you can still use it. Okay, so let me just get rid of those. Okay, and that's why, and that's where this is the study design stuff down here, and that's why you can sort of what you need to be able to do. All right, so this first video is going to be looking at basically the theory. There'll be a second video that looks at how to do the calculations, and then there's a third video where you can look at like an activity. So sudden, here's a question. What do you need to do? What are the steps you need to do? There are some other activities on the OneNote, but I've only done a video for one of them at the moment. Okay, so transformations. And this is what I've said. In case where the relationship between variables is nonlinear, the data needs to be transformed so that the pattern becomes stretched or compressed. And that, what we mean by that is it makes it more linear. One variable at a time is transformed. So we're only doing one or the other. We don't do the x and the y at the same time. We do either the x or the y. And we plot against the original value of the other variable. We'll go through, and what we're meaning here is, for example, it's y against, and I've transformed the x to x squared, or I've kept x the same and I transform the y. Same for the log here. I'm logging the x, not the y. So again, in any of those, you're going from yx to something like it would be y squared x, or log x value and y. Notice I only change one of those values. Okay, and you can do the same for reciprocal. Reciprocal just being 1 over x. All right. The square transformation stretches out the upper end of the scale on the axis. Now, I'm saying that here, I want you to keep this in mind. We'll go through some pictures in a moment of what that means. The log transformation compresses the upper end of the scale of an axis. The reciprocal does something similar, but to a greater extent than the log transformation. Sometimes you're going to need that extra bit of kick, so to speak. So here's it visually. So x, so remember we said the squared stretches at the upper end of the scale. So what it's doing, it's taking, so it spreads out the high values x relative, so it's taking, okay, here's the original data points, okay, so that's where we're getting that, and then it's taking those, so it doesn't really move these ones, but these ones gets moved a bit more, stretched out again, and stretched out some more, okay, and in a sense very similar, but on the y-axis here, I'm stretching out these ones, stretching it, so it becomes more of a straight line. The log compresses that large, so it's, when I say compresses it, it's bringing it back in. so to speak, relative to this one here. So these first two aren't moving much. As they get bigger, they get compressed back in, and it means something's coming a bit more, make it more of a linear relationship. Again, very similar here. It's just now it's on that sort of vertical axis. It's compressing it down. The reciprocal, you sort of have, often what happens is you're compressing these into the line, but you're also flipping it. So if your graph's sort of like that, so that's sort of on that, for want of a better time, on that positive trajectory, it means the linear line will be negative. Okay, you're sort of flipping it around. All right, but it's compressing it into the middle. And the same for this, it sort of compresses it down, but it's just on that that vertical scale there. Okay, now here's the summary. Put this in your summary book. Okay, you'll use it in your SAC. There's a good chance you'll use it in an exam, even just to know which one's which. So the idea is if your curve is essentially looking like that, you will pick these three transformations. If it looks like that, you'll pick those two. If it looks like this curve like that, you got to do those transformations to check which one you're going to pick. And if it looks like that, I pick those ones. Okay? Remember, what's shown here is what is going on across over there. All right? But that's what you do. That's a summary. That's what you need for that summary, what you want in your summary book. So you've got it, you can look at it and go, all right, that is what I need to use. So you don't go, which one do I use, which one do I use? You know, those are ones. Put that into your summary book. Okay. That's it for the theory. Thank you.